now we have to solve this system on our own. They give us a system of equations in 3 variables, x, y, and z. And so if there's a solution, it's going to be an ordered triple. So that's what we're looking for. Okay, so to keep things straight, I'm going to use different colors. Hopefully that will help. So we're going to use elimination. Now, if I take this equation, this top equation, you know what? I'm going to change that, sorry. I'm going to take this top equation, and what I'm going to do is I'm going to add it to the bottom equation. Now I'm going to rewrite these so you can see what's going on. All right, so over here, now sometimes I'll put an arrow like that to show you my work is going over here. So I have 3x plus y minus z equals 2. There's a lot of copy work in these problems. You have to be careful. 4x minus y minus 3z equals 0. Now what we're trying to do, there's a principle that says that if you have A equaling B and C equaling D, then you can add A plus C and it's going to equal B plus D. I'm not going to go into the details of that, but that's true. So that's what we're doing here is we're going to add the equations. Now, we can't just add any 2 old equations that we want to. I mean, we can, but we have to have it get somewhere for us. We have to have it be useful to us. Okay, so what's going to happen here is when I add these equations, see those y's? They're going to eliminate because a positive y and a negative y will cancel out. So I get this equation 7x, 3x and 4x is 7x, minus 4z equals 2. And those eliminated. That's why it's called solve by elimination. So you're trying to get rid of, one of the variables so you can work with it, okay? So yay, that worked. Okay, now what we have to do, now we have an equation that only has an x and a z, and that's great news. But now what we have to do is we have to get another equation that has x and z. So you go back to the original system, and I'm going to pick the blue equation. Okay, so the top equation, I'm going to write it over here, 3x plus y minus z equals 2. Now, if you're not using different colors, they will number them sometimes, equation 1, equation 2, equation 3, or sometimes they'll put letters, equation A, B, C, okay. But you just have to have a way of keeping track of stuff. Okay, and now, I hate to do it, but I'm going to make this the red equation. And I'm going to put that down here. 2x minus 3y minus 2z equals 1. Now, if I were to add those 2 equations together, I do not get the y's to eliminate. So I'm not going to add those 2 equations together because it's not going to do me any good. What I have to do, and I'm allowed to do this, I can multiply this top equation, if I multiply both sides of the equation, by any non-zero number I want. So any real number that's not 0, I can multiply by. It's like multiplying both sides of an equation, right? So if you had A equals B, you can go AC equals BC. You can multiply by any number you want, as long as it's not 0. Okay. So I'm going to multiply by 3. Now you might say, well, why are you going to multiply by 3? Well, you kind of have to look ahead a little bit. So see the y's, I'm trying to get those to eliminate because I want an xz equation to go with my other xz equation. And so if I had a 3y, it would cancel with the negative 3y and I'd be good to go. So that's what I'm going to do. I'm going to write them over here. I'm going to so run out of space. 9x plus 3y minus 3z equals 6. Now notice I have to distribute that 3 through the whole equation, both sides, okay? Make sure I did that right. You want to take your time on these problems because one little mistake and, changes everything. Okay, now I'm going to have 2x. I'm just copying this one down. Now, you might have a question, well, why did you choose to eliminate the y's? I just thought it would be easier to do the y's. I mean, I could have done the x's, I could have done the z's. I was just looking for what I thought might be the easiest way to do this problem. Okay, so now I need like a third color. Where are the color choices? Let's see. See if I can do a choice. I think this is going to be orange, so let's see if this works for us. Okay, adding the equations, so I get 11x. Well, let me change the size on that. Okay. And then those, the y's eliminate. Yay, the 3y, the negative 3y, they're out. Minus 5z equals, and then 6 plus 1 is 7. Okay, so now I'm going to take these two equations, this one and this one, my xz equations, and I'm going to work with those two equations. So I need a little bit of space, and where can I write them? So I have the black equation, 7x minus 4z equals 2. And then I have the orange equation, 11x minus 5z equals 7. Boy, I get to show you everything on this problem. Okay, so I need something to eliminate again, either the x or the z. I'm going to choose the z because the numbers are smaller. Now, what you're going to think about is 4 and 5, okay? What's the smallest number that both 4 and 5 go into? 20, right? So I'm thinking somewhere in my brain about a 20. And I want to have one of them be positive and one of them be negative because they've got to eliminate. So the top equation, I'm going to multiply that one by, I'll just make it a 5. Okay. And then I'm going to get, I'll write it over here, 35x minus 20z equals 10. Okay. I think I did my multiplying right. Let's make sure. Okay. The bottom equation, I'm going to have to multiply that, and you might be thinking 4, but I need it to be a negative 4 because I've got to get a positive 20z so they eliminate. Okay. Now you might say, well, why didn't you multiply by a negative 5 on the top and a 4 on the bottom? I could have, and that probably would have been easier, to be honest, as I look at these numbers, but it doesn't matter. It's going to work either way. So I just have to make sure that one's positive and one's negative. So I get a negative 44x plus 20z, that's what I wanted, and a negative 28 on the other side. Oh, I forgot to write it in orange. I know you don't care, but I'm going to write it in orange. Okay, took all that time to get the orange. Double check my multiplying, which isn't a bad idea. Okay, and now we're going to get a new equation, and I'm running out of colors, but we'll put it in purple. Okay. When I add these, so what do I get? A negative 9x, right? Those are out. Yeah, it's a negative 9x equals negative 18. Now here's where I breathe a sigh of relief. Okay, it looks like this is going to work out to be an integer. They don't have to be integer answers. They could be repeating decimals or fractions or whatever, but you know, it kind of makes me feel good that it's all working out for me. So I'm going to divide both sides by negative 9, and I get x equals 2. Okay, so some of you are thinking, wow, that's a lot of work just to get x equals 2. You're right, it is. The good news is, because we still have to find y and z, the good news is it's a lot easier to find the y and z. Okay, so what we're going to do is we're going to take that 2, and I need to go to an equation, an xz equation. So I have 3 of them that I can see. I've got the black one, the orange one. I'm going to go to this one right here because there's room for me to write. And I'm going to put in that 2 for x. So I'm going to write 7 times, and now here comes the purple 2. I'm just hoping the colors make it a little easier to see what's going on. Okay, that's an equation that only has a z in it, so we can solve it. So we have 14 minus 4z equals 2. Subtract the 14 from both sides. I think we've done some of this, but I'm just going through the steps. Divide both sides by negative 4. And z equals 3. Okay, so I got x, I got z. I have to find y. Well, how am I going to do that? I have to go to one of the original equations. So on my screen here, I can see the blue equation, 3x, I'm going to recopy it, 3x plus y minus z equals 2. So it was up here, well, bringing it down there. Okay, So now I'm going to scroll. Now I can plug in the x and the z values that I know, and I can figure out y. So it's going to be 3 times the purple 2. I mean, there's really no reason for it to be purple. Minus, and then I'm going to put in the z, which was 3, equals 2. Okay. Anyway, my colors are messed up, but that's okay. So 6 plus y minus 3 equals 2. Then I get 3 plus y equals 2. Subtract 3 from both sides. Now it looks like I'm getting y equals -1. So I found them all. I found x, y, and z. When we write the ordered triple, we have to do it in x, y, z order. So my solution is going to be 2, comma, -1, comma, 3. So you got to put it, it's got to be x, y, and then the z. Okay? So here's the answer. It's an ordered triple. We did all that. Now what if you wanted to check it? I like to check these because there's so much work. What if I made a mistake? So 2, -1, 3. Let me write that up here. 2, -1, 3. Now I'm not going to write out the check, but I'm going to look in my, just try to do it in my brain here. So if I put a 2 here, that'd be 6. Minus 1 would be 5. 5 minus 3 would be 2. Okay, it works in the top equation. So then I'm doing the bottom one. 2 times 2 is 4. 4, it'll be plus 3, so that's 7. 7 minus 6 is 1. Yeah, that works. 8, if I put 2 in there, 8 plus 1 is 9. 9 minus 9 is 0. So you could write all that out. I'm just kind of out of room and stuff, but that's how you would actually check it. You would take that solution and try it in all 3 equations. Okay? So these are a lot of fun, but they are long, and it's kind of a trick to keep track of everything. Okay? So we'll do some more examples.